Hey guys, this is Jillian Beckwith. How's it going? So I'm on vacation up in the White Mountains with my family. Say hi, family. And since we are studying Pangea and continental drift theory, along with plate tectonic theory this week, I thought this would be a great place to make a quick little video for you guys and talk a little bit about how the rocks in the White Mountains of New Hampshire formed and how we actually got these mountains, because it's a part of how Pangea formed. So before I go too far, I want to give you a little bit of information about time scales. So let's start with the whole universe. The observable universe, everything that we can see, is about 13.8 billion years old. We think it's actually even older, but we can only see as far as light travels, because that's how we see. So we can see light that has traveled about 13.8 billion years. The Earth itself is about 4.6 billion years old. Now Pangea, you would have learned through some of your readings, is about 225 million years old or so. Here in New Hampshire, I'll pan this around some, the White Mountains formed during an event called the Acadian orogeny. Orogeny just means mountain building. It's a fancy geology word. So what happened, and this is when Pangea was forming. So Pangea wasn't the only supercontinent. There was one that was before Pangea, and it broke up and it came back together. And while it was forming, about 380 million years ago during the Devonian time period, there was a big patch of land, which was called Avalon actually, and that's actually what we know as New England now. And during this mountain building event, that patch of land, Avalon, crashed into what was then North America. Now when it crashed into it, what happens is all the types of rocks that you typically see in places like New Mexico, the Grand Canyon, Arizona, things like sedimentary rock, the sandstone, the layered rock, all of that goes under a huge amount of heat and pressure when two big tectonic plates collide. So at that point we had Avalon and we had what was then formerly North America, and when they collided, all of those sediments, all of the rock that was there was under huge amounts of pressure. And when that happens, we get what's called metamorphic rock. And if you know the word morph, to change, metamorphic rock is rock that used to be something else and then it changed. So I'm going to pan around and show you some of the typical rocks that we see here in New England. So this rock, I'm down by a riverbed, so it's not the best examples because this rock has been weathered and eroded and smoothed out. But typically common metamorphic rocks that you might see around here are things like schists, gneiss, quartzites, lots of really cool mineral formations you can see in these rocks. Now, one of the things you read about in Pangea was that one of the pieces of evidence that Wegener had, one was the Mesosaurus, the reptile that he found on the eastern coast of South America and the western coast of Africa, but it was a land animal. Another big piece of evidence were mountain chains that were very similar types of rocks, similar types of geology, but they were found on different coasts. Now the White Mountains were formed after the Appalachian Mountains were formed, but all of these mountains, particularly the Appalachian with parts of Africa and Europe, they line up in Pangea if you were to put it together. Very similar types of geology. So it's kind of cool to be sitting in a place that was some of the evidence for Wegener's original ideas, which were then finally solidified when Harry Hess and Marie Tharp, who I'll mention a little bit later, she's a very undercredited woman geologist who helped find the Mid-Atlantic Ridge, but they came along with the concept of seafloor spreading, and that was the how to Wegener's ideas, and that's how we got plate tectonic theory. So I hope you enjoyed the quick video. If I see any more cool rock formations along our travels through the White Mountains, I'll be sure to stop and post some pictures or videos. Have a great day, everybody.